Well, good afternoon, ladies and gentlemen. Happy Wednesday, asynchronous day. So, we are going to talk about metallic bonding and its use in alloys. Metallic bonding is in metals, and again, we've talked about valence electrons. Okay. Now, they're talking about electrons in metals that are delocalized or free to roam about, not belonging to any one atom. They move about in what we refer to as a sea of electrons. So you can see that the electrons are not in any particular order. They're between the metal atoms. So it talks about orbitals being vacant or they're nearly empty, and they overlap and allow electrons to move freely. So metallic bond, chemical bonding formed as a result of attraction between metal atoms and the surrounding sea of electrons. The freedom, see, you can see they're moving around. To move around and in the crystal lattice accounts for the properties of metals. Properties of metals: good conductors of heat, good conductors of electricity, malleable, ductile, strong absorber and reflectors of light. Valence electrons do not belong to any one atom, so that's why they call it a sea. Free electrons allow easy thermal conductivity, so transfer of heat. When heat is applied to the metals, energy is added. Electrons move more quickly. So here's heat, and then you can see that the electrons move quickly. Since electrons are so loosely held, they move throughout the metal easily and conduct heat quickly. Free electrons allow easy electrical conductivity, so putting electricity, so like if you make this into a wire, the electricity is applied to the metal, so positive and negative, and they're attracted from negative to the positive end. So that makes sense. If we have wires, we want that to happen. We want to have them move in that direction. They move freely from the orbits to orbital, causing electricity to move freely throughout the metals. Malleable, the ability to substance to be hammered. So here's a demonstration of the bonds are the same in all directions. So one plane of atoms can slide past another without breaking. So here we're smashing it. And we can smash them even more. We're able to squeeze those together. Ductile, the ability of the substance to be drawn into or pulled through a wire. Here's a demonstration of being pulled through a wire. Wire metal shiny, that's called luster. Electrons in metals are readily available to absorb photons, which is light energy, in many different frequencies. So here is a light particle hitting, and there is the electron transmitting light back, and then electrons immediately emit the photons and return to a lower energy level, resulting in a shiny or reflective surface. Strong forces of metallic bond result in high melting points. Molten metals can be poured in together in forming metal alloys. Metals can replace other metal atoms, or smaller metal atoms can occupy small spaces between large atoms. So you can see the small spots in between in here. So this is where another atom of a different metal is moving in between the metals. So this, let's say this is iron, Fe. We add some tin to it, or if we add some carbon to it, it can fit in between things, between atoms, I should say. Iron is very corrosive and brittle in its natural form, but adding carbon, we get steel. Copper is too soft for long lasting, but by adding zinc to copper, it forms brass. Adding tin to copper forms bronze. So here is kind of a list of these. Low carbon steel, you add a little bit of carbon, only 0.1%, you get car bodies. High carbon steel, iron plus 1.5% carbon, you get knife blades and construction equipment. Stainless steel, iron and chromium, used for cutlery, doesn't rust. Brass, copper plus zinc, musical instruments, plumbing. Gold, too soft, but if you add silver and copper, you get jewelry. Sterling silver, silver and copper together. Those are the alloys. All right, so this is the end of our presentation, ladies and gentlemen. It's a short one, but there is a assignment that goes along with that. So fill that student page, use these notes to help you with that.